This video will go over your notes for Pythagorean theorem, where we're focused on using the equation to find missing side lengths. As we go through this video, please complete the notes, and then you will have time to work on your practice. Yesterday you learned about the Pythagorean theorem, and you learned about the relationship between the area of the side lengths of squares when they form a right triangle. And we got to the point where you learned a squared plus b squared equals c squared. So, there are two terms that we're going to focus on today. The first is legs and the second is hypotenuse. Our legs of a right triangle are the two pieces that make up, or the two sides that create our right angle. So our legs would be this labeled blue side and this blue side, because those two sides of our right triangle create the right angle, which can be found right here. In the Pythagorean theorem, our legs are represented by A and B. So those are our legs, and we can come over here and label A and B. The other thing is our hypotenuse. And just like hypotenuse is the longer vocabulary term here, it is going to be the longest side in our right triangle. So our hypotenuse is right here, the side that I'm labeling red. Your hypotenuse is the longest side. It is also the side that is across from our right angle. And in the Pythagorean theorem, C represents our hypotenuse length. So over here we can label our hypotenuse with the letter C. This is important to know because we're about to use this information to solve for missing side lengths in right triangles. So our legs are the two sides that form our right angle, and our hypotenuse is that third side that is across from the right angle, and it also is our longest side. We can use the Pythagorean theorem to find missing side lengths of right triangles. For example, we have this right triangle that we know two of the side lengths for. We know 12 centimeters and 15 centimeters, but we don't know this side length right here just yet, so we're going to solve for it. We're going to start by looking at our equation that we can use that relates to Pythagorean theorem. The next thing we did is we substituted in what we know. Just like equations, when we were writing them ourselves, we're going to substitute in what we know, so we're down to one variable. We know that 12 can replace B because it's a leg in our right triangle. We know that we can replace C with 15 because it's our longest side that is across from the right angle, and that means it is our hypotenuse. We can then use Desmos and type in 12 squared and 15 squared to get 144 and 225. Now it's an equation that we're able to solve. We want to isolate our variable, so we're going to subtract 144 from both sides. And when we do that, we end up with a squared equals 81. But we don't want to know what a squared is, we want to know what a is. So we're going to take the square root of both sides, and when we do that, we're left with a equals 9 centimeters. So we were able to find our other leg's length. Just as a reminder, if you're using Desmos, this is how you can put in our exponents in Desmos to help you solve these problems. So we just had to do 12 squared and 15 squared. So we're going to type in 12 first, and then over on this left panel of our keyboard, we see that A with a squared next to it, or an A with an exponent of 2. If you push that, you're automatically given that exponent of 2, and we get 144. We can do that again with 15 by pushing that A to the power of 2 button, and we get 225. If we for some reason want an exponent other than 2, which we won't need for Pythagorean theorem, then you could push your first whole number, and to move to the exponent space, you would push a to the power of b. It moves your cursor to the exponent line, and you can choose another number, such as 4. Now we're able to find that 7 to the power of 4 is 2,401. For Pythagorean theorem, we are focused on using this a to the power of 2 button because our equation is a squared plus b squared equals c squared. Okay, so with what we just talked about, our first step when we have a problem with a missing side in a right triangle is always going to be to write down our equation for Pythagorean theorem. So we're going to write down a squared plus b squared equals c squared. We're then going to identify what was given to us. So we have 8.2 representing this side length and 14.2 representing this side length. Both of these side lengths meet to create our right angle, meaning that 8.2 and 14.2 are our legs. We need to remember that our legs are represented by A and B, and we can do that by labeling them in our sketch that we're given, or just by remembering. So we're going to replace A with our 8.2 value, and we're going to attach the exponent of 2 to it. Then we're going to replace b with 14.2 and put it to the power of 2. And we're trying to solve for c, so we're going to leave that variable in place. Now it's an equation that we're able to solve. Using Desmos or your calculator, we're going to find what 8.2 squared is. And it comes out to be 67.24. Then we're going to do that same thing with 14.2, and we get 201 and 64 hundredths, and that is still equal to c squared. We're then going to add those two values together to see what a squared plus b squared truly is, using our calculator for all of these steps so we don't make any calculation errors. When we add those together, we get 268 and 88 hundredths, and that is equal to c squared. We don't want to know what c squared is, though. We just want c, so we're going to take the square root of both sides. And when we do that, we get that the square root of 268 and 88 hundredths is 16.3975, and so on and so on. We're going to round to the nearest tenth. So if I get this really long decimal, which I will because this isn't a perfect square root, that is equal to c, but we're going to round to the nearest tenth. So 16.39756 gets to round to 16.4 inches for our final answer. Looking at our second guided practice problem, we're going to start by looking at our equation a squared plus b squared equals c squared, and then identifying what pieces were given to us. So 2.3 is part of a side that creates our right angle, so it's going to be a leg, so I'm going to label it A. 3.5 is across from our right angle. It's also our longest side, which means it's our hypotenuse, so I'm going to label it with C. In our equation, we're going to substitute in these values, leaving b squared in our equation, and now we're able to solve. We can figure out what 2.3 squared is and 3.5 squared, which gives us 5 and 29 hundredths plus b squared equals 12.25. Now it's an equation that we are able to solve, and we're just going to solve for b, not b squared. So we subtract 5 and 29 hundredths from both sides to isolate our variable. And when we do that, we get b squared equals 12.25 minus 5.29 gives us 6.96. We are then going to square root both sides. And when we do that, we get our answer as b equals 2.63818. Again, we're going to round to the nearest tenth, which gives us b is equal to 2 6/10 as our final answer. Now you're going to practice this skill of finding missing side lengths using the Pythagorean theorem equation on today's practice, which can be found on Schoology.